Today I'm going to talk about a real-life example on how a player shoot the basketball into the hoop. Assuming the angle of the shooting, which is 45 degree, and the air resistance, size of basketball, and rotational kinetic energy of basketball are neglected. So, the given height of the player is 1.63 meter. The height of the hoop is 3.048 meter, and the distance between the player and the hoop is 4.19 meter, and the mass of the basketball is 0.65 kg. This is the kinematic diagram for the initial velocity of the basketball. Resolve the initial velocity into x and y component, and we will get VA sine 45 degree at the y direction and VA cos 45 degree for x direction. Using the height of the hoop, which is 3.048 meter, we minus the height of the player, which is 1.63 meter, we will be getting 1.418 meter as the length at the y direction. And as for the length at the x direction, it is 4.19 meter, which is the distance between the player and the hoop. To find out the time taken for the basketball to enter the hoop and the initial velocity, we substitute the value into the formula. For the x direction, we will be using the formula of Sx equals to uxt, and we sub in the value given, and we will be getting the first equation, which is t equals to 4.19 over VA cos 45. And for the y direction, we will be using the formula of Sy equals to V0 t minus 1 over 2 gt squared. And we sub in the value for the y direction, and it is 1.418 equals to VA sine 45 multiplied by t minus 1 over 2 multiplied by 9.81 t squared. This is the equation 2. We will be subbing the equation 1 into equation 2. So it is 1.418 equals to VA sine 45 multiplied by 4.19 over VA cos 45 minus 1 over 2 multiplied by 9.81 multiplied by 4.19 over VA cos 45 square. And the initial velocity value will be calculated, which is 7.88 meter per second. Through the value of initial velocity, we can also calculate the value of time by using the equation 1, which is 4.19 over 7.88 multiplied by cos 45, and we will be getting 0.75 seconds. And for the final velocity at x direction, it is actually equals to the initial velocity at the x direction. So we sub in the value for V0 equals to 7.88 meter per second into this formula, and we will be getting 5.572 meter per second. And for the velocity at y direction, we will be using the formula of Vy square equals to V0 y square minus 2gs. So we sub in the value Vy square equals to 7.88 sine 45 square minus 2 multiplied by 9.81 multiplied by 1.418, and we'll be getting the velocity at y direction, which is 1.796 meter per second. And to find out the magnitude of the velocity, we'll be using this formula, which is V equals to surd Vx square plus Vy square, and we sub in the value for Vx, which is 5.572, and Vy, which is 1.796. We'll be getting the value for V, which is 5.854 meter per second. And for the direction, we'll be using this formula, and we'll be getting 17.87 degree. For the conservation of energy, we will be using this formula, which is T1 plus V1 equals to T2 plus V2, in which T1 is the initial kinetic energy, V1 is the initial potential energy, T2 is the final kinetic energy and V2 is the final potential energy. The potential energy involved in the situation is gravitational potential energy. We'll be subbing the value given into the formula, which is 1 over 2 times 0.65 times 7.88 square, in which the 7.88 is the initial velocity, plus 0.65 times 9.81 times 1.63, because the basketball is 1.63 meter away from the ground, equals to 1 over 2 times 0.65 times 5.854 square, where the final velocity is 5.854 meter per second, plus 0.65 times 9.81 times 3.048, because the basketball is 3.048 meter away from the ground. So we'll be getting the same value for the left hand side and right hand side, which is 30.57 joule. This shows that the total initial energy equals to the total final energy. And this proves that it obeys the principle of conservation of energy. For the last part, we'll be looking at the application for conservation of momentum. Defender A runs toward player B, which is standing still, and they both collide together and move at the same direction before they fell down. So using this formula, which is MAVA plus MBVB equals to MA plus B times final velocity, we'll be subbing the value into the formula, which is 55 times 5 plus 50 times 0 equals to 55 plus 50 multiplied by the final velocity. The reason that we sum up the mass of the player A and B, because this is an inelastic collision, and so the mass are summed up, and we'll be calculating the velocity before they fell down, which is Vf, and we'll be getting 2.619 meter per second, in which they move towards the right.